You walk out of a tense boardroom negotiation or a high-stakes congressional hearing. Someone turns to you and says, "Well, that went perfectly." Someone else says, "That was a complete disaster." Two highly intelligent people can sit in the exact same room for an hour and leave with completely opposite realities of what actually happened. It's the Rashomon effect playing out in modern public and corporate life. We lack a shared structural artifact for dialogue. Without a way to measure the actual flow of the conversation, we are forced to judge outcomes based on flawed memories, biased opinions, and whoever happens to speak the loudest after the fact. Standard AI meeting assistants attempt to solve this by compressing the dialogue into bullet points. But this compression strips away the hidden DNA of the room, the humor that saved the deal, the tangents that derailed it, and the underlying power dynamics. Truly understanding complex dialogue requires an objective, forensic map, one that treats the conversation as a measurable system. Prism acts as an analytical lens built to map those structural dynamics. It takes the raw text of what was said and reveals the precise mechanics of how the room actually operated. This interface visualizes the narrative arc and isolates specific moments that drove the discussion, extracting structural insights directly from the raw text. The system identifies specific turning points and phase transitions within the timeline, showing exactly when the room shifted from rapport building to intense debate. The contribution tree map measures a participant's actual impact, distinguishing between people who provided high-value insights and those who simply dominated airtime. It evaluates contributions across distinct categories, scoring participants on conversation steering, collaborative building, and even silent wisdom for those speaking rarely but precisely. By providing these specific metrics, Prism gives meeting chairs, sales teams, and podcast editors the data needed to see who actually shaped the outcome of a discussion. Extracting this level of forensic detail requires highly structured, objective data inputs. Prism requires a specific transcription layout. Files must follow a speaker name text structure to accurately parse contributions. These export from recording software as plain text, CSV, JSON, VTT, or SRT. The engine rejects visual documents. PDFs or JPEGs will fail to parse. These formatting requirements serve as scientific filters. They allow the system to separate subjective noise from a clear, actionable signal. Once a correctly formatted text file is uploaded, you receive a shareable forensic map of the conversation. Because these conversations are often sensitive, data privacy is built into the system. Prism never utilizes user transcripts to train external AI models. Shared report links carry only the analytical metadata. The raw text of the conversation is never exposed, protecting legally and commercially sensitive information. This process replaces volatile but feelings with a mathematically objective reality, turning undocumented conversations into measurable assets. You can generate your first forensic analysis today. Upload any formatted transcript to the Prism dashboard to see the structural breakdown for free. If you encounter formatting errors or upload issues, our team is available to help via email. You can also use the feedback widget located in the bottom right corner of the interface for secondary support. Organizations that analyze these hidden patterns hold a structural advantage over competitors who still rely on subjective memory.